Hi, my name is Jason, along with Ethan, and today we're going to present our presentation on UML sequence diagrams. Next slide.
First, we'll talk about what a UML sequence diagram is and what it's used for. A UML sequence diagram details how operations or use cases are carried out, or it can be used to simulate interactions between the user and a system. They capture the interaction between objects that collaborate together. They are time-focused, which is implied by the sequence in UML sequence diagram. They are represented by a vertical axis, which represents time passed during the program to visualize when messages are sent or received, and a horizontal axis, which represents the different objects that interact with each other. Next slide. Next, we will discuss how to implement a UML sequence diagram. First, we'll talk about the axes, which were summarized before. The horizontal axis is the elements that are involved in that interaction, listed left to right according to when they take part in the message sequence. They can be ordered in any way, but that is typically the order that is used. There's also the vertical axis, which is the time or progression of the message sequence. So in this example, we have the computer and server, which are the elements involved in the message interaction. And going down the line, we see that send unsent email is executed first, new email, then a response is sent back from the server, then download email, and delete old email. Next slide.
All right, here what we're going to do is discuss a little bit about the symbols involved with the UML sequence diagram. So the first symbol that we have is an actor. So basically it's just a type of role played by an entity. And it does have like the external, it is external to the subject. I guess in the sense that an instance of an actor is not part of the instance of its corresponding subject. Also represents roles played by human users, external hardware, or other subjects. And something else to note is that an actor does not necessarily represent a specific physical entity, but merely a particular role of some entity. And then a person may play the role of several different actors, and conversely, a given actor may be played by multiple different persons. The next one is a lifeline. So a lifeline just represents an individual participant in the interaction. Next slide. So with activations, an activation is just a thin rectangle on a lifeline. Represents the period during which an element is performing an operation. And then usually it's the top and the bottom of the rectangle, which are aligned with the initiation and the completion time, respectively. And then next for a symbol, we have the call message. So with a call message, I guess kind of explain what a message is. A message defines a particular communication between lifelines of an interaction. So in this case, a call message represents an invocation of operation of a lifeline. And then just to kind of throw in the rest of the symbols, the majority being different messages. Here's just a list if you want to review those and go over those as well. Next slide.
So here's another example. This is a hotel system. So our elements are a window, a reservation window, a hotel chain, and a hotel. And the hotel makes a reservation, and the reservation makes confirmation. So first, the window calls make reservation, which sends a message to hotel chain, which calls make reservation, which sends a message to hotel. And in hotel, there's a loop that calls available to see if a room is available. And if a room is available, in that alternate fragment, we have a reservation is created with a create message, and a notice is created with another create message. Next slide.
So some of the upsides to UML sequence diagrams, they help you discover architectural interface, logic, and logic problems early. So this can help you to allow you to flesh out like details before having to implement anything. And sequence diagrams are useful to find architectural interface and logic problems early on in the design process. Apart from that, sequence diagrams are valuable collaboration tools. Um, they allow you to discuss the design in concrete terms. And so you can see the interactions between entities, various proposed state transitions, alternate courses, and special cases on paper as you discuss the design. And then finally, uh, it's also good for the documentation. So with the sequences, the sequence diagrams can be used to document the dynamic view. Next slide. So with the downsides are kind of some of the disadvantages with the UML sequence diagrams. Sometimes the UML sequence diagrams can be difficult to manage or maintain. And so this is, and sometimes can be a little bit more difficult to get to work properly. So UML diagrams must be synchronized with software code, which requires time to set up and maintain and adds work to a software development project. And so small companies and independent developers may not be able to handle the added amount of work required to synchronize the code. And then just a few other downsides are that they may be unclear to certain individuals working on a current project, or sometimes diagrams can become overwhelming. Next slide. And then just some recommendations, like a usage scenario when you would use a UML sequence diagram. It's like a usage scenario is a diagram of how your system could potentially be used, the method logic, just as you might use like a UML sequence diagram to explore the logic of a use case. You can use it to explore the logic of any function, procedure, or complex process. And then service logic, if you consider a service to be a high-level method used by different clients, a sequence diagram is an ideal way to map that out. Next slide.
So now we will demonstrate using the UML sequence diagram. For this demonstration, we use the 7th use case in our SDD, which describes a requirements list. And this requirements list contains queries or it queries data that is necessary to determine if a course is available to the user. Eligibility of a user for a course is determined by the requirements list. And here are the requirements that it fulfills. Requirement 8, which says the grad planner backend software shall have a student's current class schedule. And requirement 19, the system shall have access to the declared degrees course requirements. Next slide. And here's our UML sequence diagram for that interaction. So first the UI will call get requirements list, which will get the requirements list. And requirements list will call get planned courses, which will get those courses from the backend, and also get required classes, which it will also call to get the classes from the backend. Once it has done those, it will calculate the requirements, send a response back to the UI, and then the UI will display the requirements. Next slide.
And here's just a list of our citations that we used to gather information. And we hope you enjoyed our presentation, and thank you for watching.